So, welcome back. We're going to talk about creation more, and particularly about how we go from the Big Bang to the multiverse. And the underlying issue here is the universe we live in very special, and is it designed in order for us to exist? So just reviewing some of what we learnt from the Big Bang model, and where many astronomical observations were compared with the model, and things we find is that the universe is spatially flat, it's not curved, it will expand forever, it's accelerating, and there is this cosmological constant. It's not zero, contrary, and so the other thing is the composition of the universe. But the thing that I want to focus on now is the idea of fine-tuning and how special the universe is. So let me explain what I mean. So we're going to talk about what is fine-tuning, why do some scientists believe in the multiverse, and then how is this relevant to apologetics. So suppose that I told you that this was my phone number, and that was my bank account number, and that was my passport number, and my driver's license number, and that was my credit card number. That would be rather strange, wouldn't it? Because generally we would expect these numbers to be much more random. And so how could it be that if this was true? So it would tend to suggest that there was something more going on. Either maybe I was a very powerful person and could persuade all these organizations to give me exactly the number that I wanted. But it's hard to believe it would just be a random thing. So what about the laws of nature and the numbers associated with the universe? So this is where we come to something called the Anthropic principle and fine-tuning. This was proposed in 1979 by two astronomers, Martin Rees and Carter, and they suggested that the fundamental physical constants, which I'll explain what they are, that they're fine-tuned so that life can exist on Earth and in the universe. And so we might ask a simple question: what conditions are necessary for the universe to produce lots of carbon? Suppose that things were a little different. So this was the first question that was addressed. So given that there is carbon in the universe, where would this come from? Well, we talked earlier about how in the early universe that hydrogen was combined into helium, lithium, other elements. Well, to make carbon, basically you need to combine 3 helium nuclei. And so you have to get them to collide together and produce the carbon. But that's very unlikely to happen. And so what if you considered what the energy of these different nuclei are, of helium, beryllium, carbon, and oxygen, if you change their energies by less than 4%, you would produce a universe with not enough carbon and oxygen. And in fact, carbon can only be produced from helium if there's a resonance, something called a resonance in quantum theory, at a particular energy. Now, Fred Hoyle, who we saw earlier, was a skeptic about the Big Bang, a proponent of the steady state universe. He considered this question, and he predicted in 1954 that there must be such a resonance in the energy levels of carbon. And first, the experimental nuclear physicists were skeptical, but he nagged them enough that they went and looked, and lo and behold, they found this resonance within a few years. And so he said it had to be there so that carbon could be here, so we could be. And so his response to this fine-tuning, even though he was an atheist, he said, quote, "A super intellect has monkeyed with physics as well as with chemistry and biology." Now that's one example of fine-tuning. So let's talk about more. And so we have to talk about the idea of fundamental constants. So our universe obeys laws of physics that depend on these numbers that we measure in experiments, such as the gravitational constant, which tells us how strong gravity is, what the speed of light is, something called Planck's constant from quantum theory, and then the charge of an electron. Every electron in the universe is the same, and they all have the same charge, and that can be measured very carefully. And electrons have a mass, and that mass can be measured very precisely. Similarly, the mass of the neutron and the mass of the proton. And so we consider an atom. It's composed of electrons, which, if you like, orbit around the nucleus, and the nucleus has neutrons and protons in it. But suppose we considered a possible alternative universe in which some of these masses were different. Suppose the neutron was just 0.2% lighter, so it wasn't quite as heavy. Well, what would happen is all the protons in the universe would decay into neutrons, and so all we would have would be neutrons, and so which have no charge. So we have no atoms in the universe, and we'd have no molecules, and then we'd have no life. But suppose that the neutron was slightly heavier, just by 0.2%. Well, then hydrogen wouldn't be able to form, and so we would have no water, and then there'd be no DNA, and there would be no life. And so we can see that just the mass of the neutron is fine-tuned. But there's many other examples of fine-tuning like this. So if gravity was slightly stronger, then larger stars would burn up too rapidly. And if it was slightly smaller, stars would not be massive enough to produce heavy elements such as iron and magnesium and things, which are crucial for life. Now, there's something called the strong nuclear force, and this is what binds a nucleus together. It binds the protons together and together with the nucleons. Now, if this was slightly weaker, hydrogen would be the only element in the universe. But if it was slightly stronger, nuclear fission, where nuclei split apart, would occur less, and there'd be fewer heavy elements. And so we wouldn't have enough iron and other elements that we need for life. Now, if the charge on the electron was smaller, atoms, which are electrons bound to nuclei, would not exist. But if it was larger, atoms wouldn't bond together to form molecules. So I hope you're seeing that there are these, everything seems to be finely tuned. And it's not just one number, it's many different numbers. But perhaps the one that is the most striking and the strangest is the cosmological constant. And so it turns out that the cosmological constant is fine-tuned to equal the mass density of the universe to about 120 decimal places. So that's like a number with 120 digits, and they're all the same. So how can it be? Well, it's a bit like this picture that Roger Penrose, who recently received a Nobel Prize in Physics for work on black holes, but in this popular book he wrote, he drew this picture of the idea that there's God, and God can pick, when he makes all the universe, God can pick the parameters of the universe, and it's like a little pinprick in this massive space. So how might we explain the way the universe is so special? It seems to be fine-tuned. The laws of physics seem to be fine-tuned in order that we can exist, that life can exist. Well, here's 4 possible responses that you will encounter from different scientists. So one is a traditional scientific optimism, and that is that ultimately, like other things we don't understand, that we will find a theory that will explain all this. Now that may happen, but certainly hasn't happened to now, and it's so puzzling, it seems hard to believe that would happen. Another possible response is fatalism, and that is that this is just the way things are, this is the way the universe is, it's just something that we're never going to understand. A third response is the idea of teleology and design. That is, that teleology, that things have a purpose, and then that things are designed, and that God made the universe this way. God fine-tuned things so that we could ultimately exist. But then there's a fourth response, which is popular among some theoretical physicists, but certainly not among all. And that is the idea of the multiverse. And that is that that there are many universes, but and our universe is one of zillions possible. But the fact that all these numbers are so fine-tuned is just an accident. And each of the universes has different fundamental constants, but we happen to live in the one so that life can exist. So why do some scientists like the multiverse? Well, some would say it explains why fine-tuning occurs, that others like it because it shows similarities to something called the many worlds interpretation of quantum theory, which was proposed to explain the problem of Schrödinger's cat that we have encountered before. There's also something called string theory, and that predicts that there are zillions and zillions of different universes. And perhaps also because it avoids the idea of a creator. But why not love the multiverse? Well, there's many theoretical physicists, including me, who are not that enthralled with it. And the most fundamental question is that it is not experimentally testable. Because of that, there's all these zillions of other universes, they are not accessible to us. So we can't determine whether or not they exist. And since it's not experimentally testable, it's actually not science. It's really more like faith. And so the intellectual cost is too great. And The other problem is that it's not really an explanation. And so the question to ask is the belief in the universe, in the multiverse, is that actually that more rational than belief in a creator of the universe? So let's think about the implications of the anthropic principle. So is this fine-tuning just a coincidence? Should we be surprised if it were not true? We'd not be here to observe anything. So this can be understood by considering maybe a more worldly example. Let's suppose a situation where you're facing a firing squad of 100 expert marksmen and they all miss. What is your response? Seems highly unlikely they would all miss, but they do miss. So here's two possible responses because you survive. You could say, I'm not surprised that I do not observe that I'm dead. Because if you were dead, you wouldn't be around to observe it. Or do you say, I'm surprised that I do observe that I am alive. And so that, by analogy, the first one, I'm not surprised that I do not observe that I'm dead, is, in a sense, the perspective of the proponents of the multiverse. So what does all this have to do with apologetics? Well, this has been taken up by a number of apologists, the fine-tuning. And so they would say we have two clues: the creation, that there's that there's a beginning of the universe, and there's fine-tuning, and there's order in the universe. And so they would use that to argue for the existence of God. William Lane Craig and Richard Swinburne are examples of proponents of this point of view. And so one aspect of this is what's called the Kalam cosmological argument. So remember the cosmological argument for the existence of God, and that is whatever begins to exist has a cause. There is a scientific evidence that the universe began to exist. That is the Big Bang. Therefore, the universe has a cause, and God is that cause. God exists. We also talked about the teleological argument and the problems with some of the problems with that, but let's have a new version. And this is, there's scientific evidence that the physical constants are fine-tuned so that life can exist. This suggests the universe is designed. Anything that appears to be designed must have been designed by a greater being. God is that designer. So let's conclude. Science tells us our universe is very special. It appears the laws of nature, the fundamental physical constants, are fine-tuned so that life can exist. And some scientists support the idea of a multiverse to explain this fine-tuning. But it's interesting that remember that theology led to science because of the biblical worldview, but now science is bringing us back to theology, to questions of the beginning, the existence of God, and possible design.